Alright, so this is the wrap up on kinematic motion. I've went ahead and I've expressed all the equations that we know. There's a few, that I may have left off, but it's not all that relevant. The reason why I put them all up here is because I wanted to talk about kinematics in general. The really cool thing about kinematics is that we can talk about all sorts of motions here. We can talk about motions in 2 dimensions, we can talk about motions in 3 dimensions, and we can talk strictly about motion in 1 dimension. I mean, these 2 equations alone are strictly for 1 dimensions. Okay, this equation and this equation's sets of equations are for 1-dimensional motion. We talk about rotational motion, we're talking about 2-dimensional motion. We're talking about a plane, object rotating in that plane. Okay, so we can talk about all these wonderful things. As a matter of fact, if we talked about simple harmonic motion in 2 dimensions, we could end up talking about rotational motion. It would look almost identical to that. It can be done. It's not that difficult to do. You can talk about this motion and this or you can talk about taking a linear motion and a simple harmonic motion and talk about them together. Imagine that you have an object that's moving in this direction using these equations, and then moving in this direction using these equations. You end up getting a system that looks something like this. As it's moving along in distance, it's moving up and down. Okay? So it's really kind of interesting. I mean, take that linear equation idea over here and apply it with this. So let's say once again we have an object in motion like this, and then we have an object in motion like this. You end up getting helix motion, an object rotating around an axis as it's moving in this direction. You end up getting that out of there. If you can take these equations and talk about them, talk about this motion in this direction, and then talk about the rotational motion this way, you get a helix. This is really kind of cool because this kind of motion is actually the basis of a phenomenon like the aurora borealis. You have 3-dimensional motion in a sense. You have motion this way and you have the motion this way. Okay? It's really kind of interesting that you can do this. I mean, most commonly when we talk about 2-dimensional motion, we're talking about this and this. So a perfect example of that is ballistics. If we look at ballistics, you can take motion that looks like this, a bullet being fired. If you fire a bullet in no gravity, the bullet is just going to go like this. Okay? But if you introduce gravity to it, gravity being a motion down, I'm talking about using this equation to talk this way and using that equation to talk this way. You end up getting this kind of motion. Okay? So all of these equations can be mixed and matched as long as you're keeping them on different axes. If this is to talk about the x, if this is to talk about the y, or is this to talk about the x, and this is to talk about the y and the z. You can mix and match, and you get these wonderful little kind of funkadelic things going on. I mean, imagine that you have this motion, and there's a simple harmonic motion in it too. So understanding these equations and being able to use them can describe all sorts of motions that are natural in our world. I mean, that's why this is really, really important, because using what we know, we can plot, we can figure out what's going on. How is this system behaving? Why is it behaving that way? Why does it look like this? Okay? So that's why we're covering kinematics, is so that we can talk about all these complicated things. The next group of topics that I'm going to talk about, it's going to be relatively short. It's about momentum, it's about inertia. And then from there we're going to talk about Newton's 3 laws and forces. Okay, so next up is a whole section on inertia and momentum. It's going to be relatively simple. Okay, and then on to forces. Cool? So this is kind of the wrap up for kinematics. Okay?